Hello, everyone. I wanted to give you a few more examples of solving logarithmic equations. We had to kind of run through this really quickly at the end of class, so I wanted to give you an opportunity to have a video that moved a little slower um, if you needed that. So again, to solve logarithmic equations, we're going to be in one of these two scenarios. You're either going to be able to simplify it to get a single logarithm completely on its own on one side of the equation. If you can do that, then you're going to get that log completely by itself and then rewrite it in exponential form. Solve for the variable, and then don't forget to check your solutions. Now, when you check your solutions, the thing that you're looking for is to make sure that when you plug in any solutions, make sure that any stuff inside a logarithm is strictly greater than 0. We can't take the log of a negative number. We can't take the log of 0. So if any solution creates a negative number or a 0 inside a logarithm, we have to toss it out, and that can't be a solution to our equation. So that's the process if we can get a single log by itself. And if we can't do that, then the other situation we'll find ourselves in is that you will be able to simplify your original equation to get a single log on either side of the equation. So you'll have log base b of thing 1 equaling log base b of thing 2. If you can simplify to that form, that's the first thing that you're going to want to do. Get each log completely by itself on one side of the, or on both sides of the equation. And then if you have log base b of one thing equaling log base b of another thing, and they're equal, we're doing the same process to two numbers and getting the same thing. What that means is that those two things have to be equal. So you're going to set the stuff inside the logs equal to each other. Then you're going to solve for the variable. And again, make sure that you don't create negative numbers or zeros in any logarithms. If any solution does, toss it out. Okay, so let's practice this. So number 2, we're going to solve each of these and when necessary, round to the nearest thousandth, so 3 decimal places. All right, so number 2 is 5 times log base 3 of x plus 11 equals 5. We only have one log in this whole equation, so we are definitely in case 1 up here. So we want to make sure that we get that log completely by itself on one side of the equation. Our log is right here. We have to get that completely on its own. We have a 5 out front, so we got to get rid of it. I'm going to divide both sides by 5 to do that. When you do that, that 5 is going to cancel. You're going to get log base 3 of x plus 11 equaling 5 divided by 5 is 1. Now the log is completely by itself on one side of the equation, and we can now rewrite this in exponential form. So remember to rewrite it in exponential form. The base of the log becomes the base of an exponential on the other side. So we get x plus 11 equals 3 to the first power. That's rewriting this in exponential form. And then from here, we just got to solve it. You'll subtract that 11 from both sides and get x equals negative 8. Now we just got to check and make sure that this is actually a solution. So you're going to take that negative 8 and plug it into your log. You really don't have to check the kind of all of the answers to make sure that both sides of the equation are equal. Really what we're looking for is to make sure that anything inside a log is greater than 0. So when we plug in negative 8, what we have inside this log is negative 8 plus 11. That's 3. 3 is greater than 0, so we are good. And that means our solution is x equals negative 8. All right, I want to work through number 4 here as well. Now, this one, we've got 2 logs. So you might think that we are now in case 2, where you want to get log base b of thing 1 equals log base b of thing 2. But there's a wrinkle here. I've got log base 2 of x minus 2 completely on its own over here, which is awesome, but I don't have a log completely on its own on the other side. I have a plus 2 connected to it. That is not allowed. Um, for case two, you will be able to get both logs on each side of the equation with nothing else with them on either side. So this actually is not case two. Even if we try to move that two over, if we subtract two from both sides, then we're in the same situation where log base 2 of x minus 2 won't be by itself anymore. And that still doesn't work. So we're actually not in case two, we're in case one. So if we're in case one, we need to get a single logarithm on its own on one side of the equation. Well, how do we do that? Well, we're going to start by putting all the logs on one side of the equation. So I'm going to add this log base 2 of x minus 5 to both sides. And I get log base 2 of x minus 2 plus log base 2 of x minus 5 equaling 2. Okay, I guess we're warmer, but we still have two logs over here. But I've got two logs connected by addition. If I've got two logs connected by addition or subtraction, I can condense those down into a single logarithm. So I'm going to create one log base 2, and I'm going to put my toys away. X minus 2, that is, has a positive log, so it's going to go on top. And this x minus 5 also has a positive log, so it's going to go on the top shelf. Technically, nothing's on the bottom shelf, which means there's a 1 down there. So really, I have log base 2 of x minus 2 times x minus 5, right? Addition outside turns into multiplication inside. And so we don't really have any division. That's why there's really nothing on the bottom here. So whether you write that over 1 or not is kind of up to you. Okay, so now that I have that, I have a single log on this side completely by itself and a number on the other side. So now we can go ahead and rewrite this in exponential form. The base of your log turns into the base of an exponential on the other side. And so we get x minus 2 times x minus 5 equals 2 to the second power. Now we just have to solve this out. You're going to FOIL everything out on the left. When you do that, you're going to get x squared minus 7x plus 10 equals 4. To get that minus 7x, I really multiplied the outside and the inside. I got minus 5x minus 2x, and I combined those. So you just want to make sure you FOIL, and you'll see where that minus 7 came from. So now to solve this equation, I have an x squared and an x. I'm going to put everything on one side and see if I can factor this. So I'm going to subtract that 4 from both sides, and I'm going to get plus 6 over here equaling 0. To solve this out, I'm going to factor. So we will have x, let's see, two things that multiply to a positive 6 and add to negative 7 is negative 6 and negative 1. So now I can set each factor equal to 0, so x is either 6 or 1. All right, and this is a log. Don't forget, we have to check these. You have to check both of your solutions in all of your original logs. So if I check x equals 6, I'm going to plug it into both of my logs here. So log base 2 of 6 minus 2. And if I plug it into the second one over here, I would have log base 2 of 6 minus 5. All right, 6 minus 2, that is greater than 0. That works. Log base 2 of 6 minus 5, that's 1. That's also greater than 0. So this is good. X equals 6. It checks out. And I also have to check x equals 1 in each of these logs. So if I start with this log on the left, I get log base 2 of 1 minus 2. 1 minus 2 is negative 1. That is not greater than 0. That's less than 0. I have a negative inside a log. That means I have to get rid of that solution. And that means that the only solution that I have for this problem is x equals 6. All right. How about number 5 here? If I want to solve this one, this is actually case 2 now. I've got one log on either side of this equation. I've got log base 4 of thing 1 equaling log base 4 of thing 2. The only way for those two things to be equal is if thing 1 is equal to thing 2. So we can just kind of logic out that what the things inside the logs have to be equal. We'll set them equal and solve. So you'll subtract 1 from both sides. That means x equals 17 over 2. And don't forget to check it. And so we basically just have to make sure that when we plug 17 over 2 into our log, what we have inside is greater than 0. And 2 times 17 over 2 is 17 plus 1. That's 18. That's greater than 0. We are good. And there we go. And x equals 17 over 2 is our solution. Okay, we will do one more example. How about we will just do this guy number here, number 6. All right, so we've got ln of x minus 3 minus ln of 2 equals ln of x. I've got 3 logarithms here. Which case am I in? Well, that kind of depends on you. If you wanted to, you could put all of your logs onto one side and combine everything into a single log, and then you would have one log with a 0 on the other side, and then you would rewrite it in exponential form. But I like to go to case 2 if I can. I think that most people do better with just setting things inside the logs equal. Um, just generally, that tends to be an easier process than rewriting an exponential form. But this is a choose your own adventure. You'll get the same answer either way. So I'm going to turn this into case 2, and I'm going to combine these two things on the left. ln of x minus 3 minus the ln of 2. Well, I'm going to condense those into a single logarithm. I'm going to put my toys away. X minus 3 has a positive log. It goes on top. And 2 has a negative logarithm. It goes on the bottom. So I'm going to combine these into a single log. Subtraction outside turns into division inside. And then I have an ln x on the other side. So now I have ln of thing 1 equals ln of thing 2. The only way for that to happen is if thing 1 equals thing 2, and now we can solve this out. So I'm going to multiply both sides by 2. I don't like the fraction. And now I'm going to subtract that x. So I put all my x's on one side of the equation, and I get x equals negative 3. But don't forget we have to check it. So let's go ahead and make sure that we don't have negatives in any logs. So if I take x equals negative 3 and plug it in here, I get negative 6. That is less than 0. I can't do that. So that means I have to toss out that solution. And that was the only one we had. So if we have to toss out the only one we have, then you have no solutions at all for that equation. All right, I hope that helped with solving logarithmic equations. Again, I just wanted you to have a couple of examples that moved at a more digestible pace for you. So happy solving logarithmic equations, and I will see you next time.